reviewing today for the Chapter 11 test. We have some formulas that we will be using today. They'll be on your formula sheet that you will have access to on the test. So for our arithmetic sequence, right, we can find any term by taking the first term and adding it to our common difference multiplied by n minus 1. Right? Shows up on your formula sheet like that. So we will use that formula, and we will also use the formula for the sum of terms. Right? So the sum of a certain amount of terms is equal to our n value over 2 times first term plus last term. Okay, so those are the equations that we are going to use for today for problem 1. So always helpful to label your terms, right? So my A1 here is 17. My n values are going to be these values here. Those are my n's. And then my common difference is going to be -5, right? Second term minus first term, be -5. So there is my information that I will need to be successful on all of number 1. Part A asks what is the 10th term. So we're going to use that first formula, this formula here, right? A10, because I know my n value is 10, is equal to my first term of 17 plus n minus 1, right? So 10 minus 1. And in reality, I would probably just simplify that as I wrote it, right? So let's go ahead and do that, right? Let's just put our 10 minus 1 as a 9 there, and then times our common difference of -5. And I put parentheses in there to highlight, especially in this one, this negative common difference. And then that just becomes calculator 17 plus 9 times -5. So our 10th term then is -28. Our 100th term, we're going to do the same work. We're just going to change that n value. So it's going to be 17 plus 100 minus 1, which would be 99, times -5. So 17 plus 99 times -5, -478. For C and D, we're going to use this second formula here, this summing formula for part C. I'm going to work part C right here. Sum of the first 10 terms is equal to my n value of 10 over 2 times A1 plus AN, so the 10th term, which is a -28. Now this one gets a little tricky because we have a negative value, right? So I'm going to need an extra set of parentheses there, right? So I am going to say that this is 5 times. On my calculator, I can go 17 plus a -28. You might also recognize that you can just do 17 minus 28. That works as well. You get -11. And then when you multiply that out, you get a sum of -55. So the sum of those first 10 terms is -55. For part D, using that same formula, we're just swapping out our n value to 100. So 100 over 2 times n1, or a1, sorry, plus my a100, which would be the negative 478. Right, so in my calculator, 17 minus 478. So I get 50 times negative 461. Right, times 50. So my answer here, negative 23,050. So negative 23,050. Moving on to number 2. This is a geometric sequence. So we're going to move on to the geometric sequence part of the formula sheet. To find a term, you take the first term and multiply it by r to the n minus 1 power. To find the sum, right, the sum formula is a1 times 1 minus r to the n power all over 1 minus r. And that's probably the most difficult formula that we'll use on this test. So part A and B ask us to find specific terms that we are going to then use for parts C and D. Right, so for part A here, well, for all of this, we have an A1 value of 2. These are going to be our n values. And then our common ratio is going to be second term divided by first term, which would be negative 3. So for part A, term 5 is equal to term 1 times common ratio to the n minus 1 power. So 5 minus 1 is 4. And then I just calculator that. 2 times negative 3 to the 4th power, like that. Equals 162. Okay. For the 7th term, I'm going to do the same work, except I'm just swapping out the n value. 7 minus 1 is 6. Right, so 2 times negative 3 to the 6th power, 1,458. For parts C and D, we are going to use the sum formula here for that, finding the sum of a series. And so our sum of our first 5 terms is going to be equal to our first term of 2 times 1 to minus r, which is negative 3, to the n power. And then all over 1 minus r. Okay, so this is going to become a denominator of 4. Then 1 minus a negative 3 becomes 4. And then the numerator I am just going to type into the calculator. 2 times 1 minus the negative 3 to the 5th power. And I get a numerator of 488. And reducing that would be 122. For part D, we're going to do the same work, except we're changing our n value to 7. And so, other than that, the problem will remain the same. Right, A1, 1 minus a negative 3 to the 7 power, all over 1 minus r. Right? So I'm going to have a denominator of 4 again, and I'm going to again type that into the calculator. Shortcut is second enter, brings back up what your previous input into the calculator, and then I can just edit the 7. I get 4,376, and when I divide that by 4, I get 1,094. 1,094. And once you're through that, that is the worst of it for this quiz. Arithmetic means, right? We're looking, how do we get from term to term? But they don't tell us all of the terms, and they don't tell us that common difference. We see an overall difference there of 120 minus 64, right? So this is a big jump of plus 56. We're going to divide that into 4 smaller pieces because there's 4 little jumps. So 56 over 4, which would be 14. Right, I should have done 56 divided by 4, not 56 divided by 14, but confirms my thinking there. And then we're going to add 14 to the 64. Right, so it would be 78, then 92, and then 106 to fill in those missing terms. For the geometric means, right, we have to think about multiplication. What number times 1 is 81, or I can do last term divided by first term. Okay, so this has a big jump of multiply by 81. I need to partition or section this up, and notice I did not use the word divide because I am not going to divide like I did in number 3. I am actually, since there are 4 jumps, I am going to take the 4th root of 81, right? Because this is multiplication. I want to know what number to the 4th power is equal to 81. That will give me that common ratio. Probably should have used an R instead of N, but common ratio to the 4th power would be 81. So on the calculator, I can either type in my 4 before hitting the math button, number 5, right? So that tells the calculator that that little x next to the radical there is a 4. And then I can type in the 81 for an answer of 3. So I'd have a common ratio of 3. I can also take 81 to the 1/4 power. Also see the same 3. So my common ratio here is 3. So it'd be 3 times 3 again is 9, times 3 again is 27. And then 27 times 3 finishes it out and gives us the 81. Infinite geometric series would be the last formula on your formula sheet. Sn equals first term over 1 minus r. So this only works when we have an r value that has an absolute value between 0 and 1. That would be the only time you can find the infinite sum. And I see here, second term divided by first term would be 1/2 or 0.5, right? Multiplying by 0.5 all the way across. And I have an A1 value of 44, right? So for number 5, that sum would be 44 over 1 minus 0.5. 1 minus 0.5 is just 0.5, right? 44 divided by 0.5 would be 88. 44 divided by 0.5 would be 88. Repeating decimal, we looked at lots of different ways to do that. Some fancy algebra, counting the places and putting nines as a denominator. Right, the simplest way with the least amount of thinking would be to enter that repeating decimal into your calculator. So decimal point, and in this case, since it's 1/8 repeating, at least a line of 1/8, and then I can hit math option 1, which says, hey, make this a fraction, right? 2/11. Recursive sequences. So in number 7, we get a first term of 4. So I'm just going to enter that 4 into the calculator. I can put that here on the first line. They want the first 5 terms. And then my formula here is to multiply by 3 each time. So I can hit times 3. 4 enters gives me my next 4 terms. 12, 108, 12, 36, 108, and 324. For number 8, I have a first term of 3, and then my formula then is 2 times the previous number plus 3. Right, so I'm going to use the same strategy, enter the 3, and then I'm going to go times 2 plus 3, 9, 21, 45, 93. So 3, 9, 21, 45, 93. Okay, there is no direct formula to get to a direct term on a true recursive. Closing out with some story problems. So we have a theater, 23 seats in the front row, right? So here's our stage, 23 seats, and then more rows, and it tells us each successive row contains 2 more seats than the previous row, right? So this one's going to have plus 2 for 25, plus 2, right? So this is an arithmetic sequence. They want us to find out how many seats are in the last row, the 28th row of the theater. So A28 equals, and for an arithmetic, we take first row plus our common difference times n minus 1, right? So 27 additional rows times 2. And that would give us an answer of 77. So there's 77 seats in the last row. And then question B asks us how many seats then are in the theater. So that would be the sum of the first 28 rows, right? So I'm going to take my n over 2 times first term of 23, last term of 77. Okay, and then I can do that in the calculator. 28 over 2 is 14, and then multiply that times 23 plus 77 for an answer of 1,400 seats in our theater. Number 10, a virus infects the files of a computer. One initial, and then the number of files doubles every minute after that. So how many files are infected in 16 minutes? So we want to find A16, and we're going to use the geometric formula of A1 times my common ratio. Well, doubles means times 2 to the n minus 1 power, right? So 2 to the 15th power times 1, which is just 2 to the 15th, is 32,768 infected files in 16 minutes. Tech department would not be super happy with that. And then we have a recursive, a true recursive here to finish out the quiz. So we have 5, 3, 8, 11, 19. They say the third term here of 8 is found by adding the previous 2 terms. Fourth term is found by adding the previous 2 terms, and so on. Right, so to build this, they want the 10th term. We cannot go directly to the 10th term. We're going to have to build all 10 terms. right? So that's what we know. And then we know the next term is going to be this 11 plus 19, which is 30. And then 30 plus 19, which is 49. And then 30 plus 49 is 79. And 49 plus 79 is 128, which I believe is the ninth term. And then 79 plus 10 or 128 is 207. Right? And you could calculator that up as you go to get that work. But you're not going to be able to use any formula to jump right to your 10th term. So that is it for our review. Quiz will be coming up soon. Be sure to ask questions if you need help.